All right. So what I'd like to talk about next is this idea of what's called A/B testing. And it's a way for us to compare two different samples. And so the idea here is, and companies do this all the time. Google is always doing A/B testing. And it's a way really of comparing two samples to one another. And so if we have, excuse me, if we have a bunch of sampled individuals from group A, and we have a bunch of individuals in group B, the question we want to ask ourselves, so we've got a bunch of data from group A, a bunch of samples from group B, and we want to ask ourselves, do the values from group A and the values of group B come from the same underlying distribution? Another way of saying that is any difference we see from our statistic from group A and group B due to chance, or is there actually some underlying difference between the groups? So that's the question we want to answer. Do the values that we get from those groups, do they come from the same distribution due solely to chance, or is there an inherent difference? Is there some model kind of going on from there? And we can do this by a technique, and it's a technique we're going to learn today, and it's called A/B testing. Okay, and so let me show you kind of some of the tools that we're going to use to do this. Okay, and so the demo that we're going to use here is it's going to come from a table about births. And so they collected a lot of births, and basically the question that they wanted to ask was there any difference from mothers who smoked while they were pregnant and mothers who did not smoke from there? And so these are going to be the two different samples that we're going to look at in this group. So women who smoked while they were pregnant and the non-smoking group. And so they took a lot of different, they kind of recorded a lot of different statistics. The one we'll focus on for this example, we'll look at birth weight. Okay. And so to get that, so here's our table of births. The only columns that we're interested in is whether the mother had smoked, was a smoker, and we just want to look at birth weight. Though you can do similar analysis to other types of things like the length of pregnancy and the other statistics that they calculated from here. So what we're going to do is we're going to take that table and we're just going to select the two columns that we're interested in, the smoker column and the birth weight column over here. And so what we can do is we can just kind of get some summary statistics of our table. We can just use the group function. And if you remember, the group function is going to, if we pass it in a column name, and it's going to group all of the individual, this is a categorical column, so it's going to group all of the smokers together with the non-smokers. And the default is to perform a count. So this will just give us a new table that has the count. Okay, so for this experiment, 715 of the mothers were non-smokers, 459 were smokers. Okay, and so let's plot a histogram of that. And so let's get a distribution of that. And what's nice is that we can use the group option to the histogram. So here's our table, right? So this is just our smoking and birth weight table. It just has the two columns in it. We'll compute a histogram, but what we can do is that we can let the histogram function do all the heavy lifting for us. And this will create two distributions on the histogram based on groups. So it's going to collect all of the non-smokers together. It's going to collect all the smokers together. And then it's just going to show us the distribution, the histogram of both of those. That's nice. That's kind of a nice thing to know that the histogram will do for us. And so if we show this, and in here we're just kind of, visualizing it, looking at the data and get a sense of maybe whether there's something here or not. So in this case, if we look at the smokers in gold and look at the smokers, the non-smokers in blue, we can see that, and this is birth weight in ounces. And so you can see just by kind of eyeballing the distributions, it does seem kind of at a high level that the birth weights, the distribution does look shifted over to the left here. from there. And so perhaps maybe that we are on to something, that maybe there is a difference in birth weights from there. Okay. Any questions? Like how, actually, any questions kind of how I got all of that data from there? It's just all the techniques that we've kind of, we've learned up until this point. Okay, so the groups for this particular experiment, right? So when we do A/B testing, kind of the first thing that we want to know are what are our groups? We have to figure out what our two groups are going to be. In this case is the pool that we're picking is the random sample of newborns, right? Because that's not right. Well, the data that we have is just a random sample of mothers and newborns. It's not every mother and every newborn. So what we have is a sample. So and so we have this random sample, and so we're going to compare the birth weights of babies of mothers who smoked versus the weights of babies who didn't smoke. Okay, and so those are the groups: the non-smokers, the non-smoking moms, and the smoking moms. Then the question is, because we saw looking at the distributions, you know, is any different in birth weight? Is that due to just chance alone, right? Is that due to chance alone, or is there some underlying difference between the two groups? So that's the question that we're going to ask. Were the results that we see due? What is the probability that it's just due to chance? And so how are we going to do that? So we're going to come up with our null hypothesis, okay? And the null hypothesis, kind of getting around this idea of that this was done solely due to chance. The null hypothesis, the distributions of birth weights are going to be the same, right? So the null hypothesis is that whether you smoked or not makes no difference on the birth weight, okay? So any difference that we saw in those histograms are just due to sampling, just sampling chance. So that's our null hypothesis, that there's no difference in birth weights. The alternative hypothesis is that the babies of mothers who smoked weighed less on average than the babies of non-smokers, okay? So that's our null and that's our alternative. So then now we're gonna wanna come up with a test, the test statistic, okay? In this case, we have our two groups, smokers and non-smokers. And really what we wanna look at, the statistic, and which goes, you know, to our alternative hypothesis, the statistic we want is the difference between the average weights between the two groups. So we'll take the two groups, we'll take their average weights, and we'll compute the difference from them to see if there's any difference between those two groups. And we'll do it this way. We'll take the group B average, and if you remember, group B is the non-smokers, which we think are going to have heavier babies, and subtract that from the group A average. Okay, and so then the question, you know, of the statistic, large values of the statistic favor the alternative, right? So the larger the value of the statistic, that's rejecting the null hypothesis from there. Okay, so we're going to see kind of, yeah, so from there. Any questions about that? So kind of to do this A/B testing, we need to figure out what the groups are, and we need to figure out what is the statistic that we're going to measure. Once we have that, then we can, and then we can, once we can, you know, once we have all that squared away, then we can actually go and do the simulation. All right, so now what is our test statistic? Our test statistic here is going to be this difference in birth weights. So let's think about how we're going to do this, and let's think about a good way of doing this programmatically. So first, let's just kind of take the statistic by hand. And so what we're going to do here is we're going to get a means table, okay? And what's going to be in that means table is just the average between the groups. And we're going to take advantage again of the group method on tables. And so if you remember how the group method works, we give it a table, and then we give it a column name, we give it a label, And if you remember our table up here, we're going to group by maternal smokers, right? So it's going to group all of the smokers that have the value true with all the values, with all the members of the group where it's false. And so this is our smoking and birth weight table. So this is the one up here. Down here where we're just taking the smoker and birth weight columns. And so it's going to group them into individual arrays, and then it's going to calculate whatever function we pass in as this argument. And so it's going to take the average of each of those groups for us. It's going to take the average of those, and then it's going to make it us a table from there. Okay. And so you can see just by looking at the table, there is a difference between the averages from there, right? And if you were a smoker, your birth weight average was smaller than if you were a non-smoker from there. Okay, so let's just kind of finish this and actually get our observed statistic, which is going to be the difference in the weights. And we can just do this by subtracting from the columns, right? So let's just take our means table, and we're going to extract our columns. So that's just going to give us an array of means. And we're just going to take the first element from there, the non-smokers. So means item 1 is the first element in that means array, and we're going to subtract it from means item 1, the second element in that array. And that's just going to give us the difference. And you can see the difference on average between the two different groups. The non-smoker babies were 9.2 ounces heavier from there. Okay, but that again, that could just be due to random chance from there. Okay, so so those are the steps that we use to go from our table to the actual statistic. Since we're going to be running this, as a simulation, we're going to be computing the statistic over and over and over again. It makes a lot of sense to put that into a function. Okay, so we're going to take all of the work that we've done up here, we're going to bottle it into this function here, and we're going to call this difference of means. And what's nice is the way we've written this function, it's a generic function that can work with any table from there. And so you can see we're taking 3 arguments. We're going to pass in a table. So that's going to be the table we're going to want to compute this difference of means on. And then we're going to take a label, and that is going to be the label that we're going to compute the statistic on. And in this case, this is going to be our birth weight label. And then we're going to take the categorical label, the group, how to group. How we're going to do the group. And in this case, this is going to be, for our example, this is going to be the maternal smoker from there. And so we're just going to perform all the steps that we did in the individual cells. We're going to take our table, and notice, right, because it's just a generic table, it's whatever table we passed in. So we're using the function name table. And so we're going to select, we're going to select the 2 columns that we care about, the label and the group. So that's our reduced table, and that's exactly the steps we did before. And then here, we're just going to use our group function to compute the average to our means table, just like we did before, but we're just using the generic function names that get passed into the function. And then we compute them, we return the difference here. Okay, so now that we have this function, we can run this on any table that we wanted to compute this difference of means on. And so let's, just as a sanity check, to make sure that our function is working properly, let's run it on our code. So let's run it on the table that we've computed by hand, right? If everything works properly, we should get the same value of 9.2 up here. And in fact, when we run that, we do. Okay, so now we have a function from there. And so now that we have our statistic, we have that, now we can put the whole thing together. And so how does this A/B testing work? This A/B testing works in the following way, and this is kind of cool. And so we're going to simulate under the null hypothesis. And remember what the null hypothesis is. The null hypothesis is that there is no difference between the groups. There is no difference whether there should be, if the null hypothesis is true, there's no difference whether you're a smoker or a non-smoker with regards to baby birth weights. So what we're going to do this simulation is, so we have our data, we have our birth weights for all of the individual ones, either whether you're a smoker or a non-smoker, a smoker or non-smoker. But if our hypothesis is it doesn't matter if you smoked or not, well, what we can do is we can just, get ready for the fancy animation. We can just shuffle all of the names of smokers and non-smokers. We can take the labels and we can shuffle all of the labels and put them back randomly. Okay. And if there's truly no difference, between the groups, the smokers and non-smokers, groups A and B, shuffling the labels won't make any difference. From there. And so that's exactly how we perform this null testing. We're going to take all of the labels, we're going to take the birth weights, we're going to keep them the same, but we're just going to shuffle. And so what I mean by shuffle is literally just kind of put all the labels, in a hat, and we're just going to pull them and assign them to each of the individual birth weights now. From there. Okay, so like I said, if the null is true, these rearrangements that we're going to do isn't going to matter. So what we're going to do is we're going to shuffle to run our experiments, and this is kind of the framework. This is kind of like the key slide, and this is how you perform A/B testing. And this is the framework that you'll use kind of for any type of things that you do A/B testing. So you're going to shuffle all the group labels. So all of the group labels, we're going to shuffle them. And then what we're going to do is once we shuffle them, we're going to assign the birth weights to group A and group B, but we're going to maintain the group sizes, right? So we're going to keep that proportion of group A, had the whatever the original size was for group A and the original size of group B. So we're going to keep that constant, but we're going to reshuffle. We're going to reshuffle those labels from there. And then we're going to find the difference between the averages of the two groups. And then we're going to repeat. We're going to run our simulations, and that's known as our permutation test. And then we're going to look at the distribution. We're going to look at the histogram, the distribution of all of those empirical values, and we're going to see where our observed value falls from there. Okay, let's put all of that together. All right. So how do we do this shuffling? So let me show you kind of a stripped down example of how we do the shuffling before we do it on the larger data set. So here I have a table, and this table I have the letters A, B, C, D, and E. Okay. And so if you remember, when we have a table, we can call sample. And what does sample do? Sample will pick random rows from your table, but the key here is that it will pick them with replacement. It's going to basically, when you draw something out, it's going to put it back in. So in this case, notice that we got, wow. I mean, and this is perfectly, normal due to chance, but B was a very lucky number, very lucky letter, right? We drew that 80% of the time from there. And so that's not exactly what we want. But I mean, again, if we run this again, we can see that we'll get different distributions, but we can see that we're going to get the same one, right? If we're shuffling the labels, we actually want them shuffled. We want the same number of trues and falses of smokers and non-smokers to appear, right? We don't want to change the number of smokers and non-smokers for that. And so what we're going to do here, so instead of sampling, all we need to do is sample with replacement. Okay, with replacement turned off. So if we set with replacement set to false, that's going to guarantee that, and if we sample the whole table, that's going to guarantee that each letter shows up exactly once. Every row will appear from there, and you can notice that it's unique. And if we run it again, time and time again, each letter shows up exactly once. Okay, so that's what we're going to do to shuffle our labels, and we can do it just kind of with this line here. So we're going to take our letters, and so what we're going to do is we're going to take our letters table, and we're going to add a new column to that table. We're going to call that the shuffle table, and that's going to be the column with the labels shuffled. Okay, so we're taking letters, we're going to add the column shuffled, and what do we add it with? We're just going to add it with this random, this sampling without replacement. Okay, so this letter sample with replacement will return us the new table, and here we're just taking the first column from that table, right? So because this is the table that it would give us, the table of letters, and we're just interested in adding, because we need, with column, we need to add a column. So we're going to extract the first column from that. Okay, so that will give us a table with our original column, with our original letters, and those are shuffled, and they in fact are random, right? Any questions about how I did that? So we're just taking the labels and we're just shuffling them around, keeping all of the groups the same number of each group from there. Okay, so now we have kind of almost all the tools in place. All right, so let's look at our baby table again. This is all the stuff that we did on the previous exam, previous notebook. We extracted out the smoker and birth weights. And so now here's where we're shuffling our labels. And then we're adding them back to our original table. Okay, so here we are. So here's the first two columns is our original table, and these are the shuffled labels. And you can see, right, we only have true and false, so you're going to get a lot of tables that, don't appear to change. But in fact, we can verify that this column right here, highlighted in blue, didn't change. This changed, right? So in fact, we did end up, shuffling the labels. And again, here is our difference of means. This is the exact same function that we looked at in the previous demo. And so we're just going to define that again. And so now we can actually compare. So we can compare. So what we're doing here is so here's showing, because we've computed this table here, right? So this is the one with shuffled labels. And so now we're just going to use this difference of means to compute our statistic. Okay, so we're passing in the table, and notice, right, the way this works is we pass in the table, we pass in the column that we're going to compute the statistic on. That's going to be the birth weight. And this is the label that we're going to use for that. So for this, to see the difference in our statistic for our shuffled label, we would pass in the shuffled label from there, and we can see that the difference of means between the two groups is 0.5, so half an ounce from there. And if you remember, what did we get originally? So again, I'm just calling our same function that calculates the statistics on the original column, the maternal smoker column, and we can see that we get a larger one. Okay, but remember, again, this is just one test. This is just one test. We're not going to really have some confidence until we actually run this, thousands of times. Okay, so how do we do that? Again, this is where we're gonna take this, and we're gonna take our difference of means, and we're gonna put this together to do one simulation. Okay, so this is going to combine us creating the new table with the shuffled labels. These are all the things that we've done before. We're just putting together into one function. And so here is where we're going to create. So again, we're passing in the same thing, this has the same signature. We're going to pass in, this function is going to take the same arguments and the same types. It's going to take the table, the label that we're going to keep the statistics on, and the group label for dividing up the groups. Exactly the same thing as our difference of means. But what this is going to do is this is going to take our table, and this is going to do the shuffling for us. Okay, so this is going to do two things. It's going to do the shuffling and computing the statistic for us, and it's going to return a particular one statistic of a shuffled. Okay, so here's we doing the shuffle, and then we're getting the shuffle table, and then we're just calling our helper function difference of means on our newly shuffled table that we're created. So every time we call this function, we're going to create a new shuffled table and then compute the statistic on it. And so this is going to be one trial of our simulation. Okay, and so now we can run this. We can pass in our table. And then our, this is the table, the column we compute the statistics on. This is our grouping table. And so if we run this, every time we run this, we'll get a new statistic. Okay. And you can see it changes each time. And there's some variance here, right? From there. Okay. The final step to this, the final step to putting all of this together is let's run our experiments. Okay. So now we have the whole thing. We have our function, which will run one trial, will compute one statistic for us with the shuffling. Now what we need to do is we need to run that a few times so we can generate the histogram. And we do that using this accumulator pattern that we've seen before. And so how does the accumulator pattern work? We're going to need to come up with a name to store our results. And so we're going to call this the difference, and we're going to initialize this outside of our for loop. And this is just going to be the empty array. This differences will hold all of our results. And here we're using the for loop just to simulate 2,500 times. and you'll see why I'm choosing a lower number. This simulation takes a long time because we're creating a new table for every simulation, and we're doing the random shuffling from there. And then we're just going to call our simulate one difference to generate our new statistic. And we're going to save that as new difference. And then we're going to append that to our differences array. Okay. So by the end of this, we will have an array of 2,500 elements, each doing one of them trial. And this is going to take a while. I should have ran it. If I was thinking ahead, I would have ran this and then explained what was going on through there, because it's probably going to take about a minute or so to run from there. So this is a perfect time to ask, do you have any questions about kind of what I've done here? Any of the Python code, anything really? We got a minute. And I have it under good authority. If someone asks a question, it actually speeds up the computation due to quantum effects. All right, I'm making that part up, but if we do talk, if someone asks a question, it will make the time go by faster, or appear to make the time go by faster. That is true. Or we can just take a moment and relax. That is absolutely fine too. We're done. We're done. Fantastic. So, okay. So now we have our array of differences. Okay. So the last thing that we want to do is, so we have our differences. And so let's compute our difference of means here. So now we have our table. So now we have our column. Okay, so we have our column, which we'll put in our table, which will compute our histogram. And so this right here, this is just getting in a variable our observed distance, our observed difference. Okay, so that's the thing we did up here that has the value, this thing right here. So this is the exact same line. I'm just storing this in this variable observed difference, so we can kind of print that out and display them. So here is kind of the grand reveal from that, where we're going to take. We're going to get a histogram of our experiment. So remember, differences is just an array. Okay, so to use the histogram function, we're going to need to convert that array into a table. And so here we do it with the table function, right? The table open close paren, that creates a brand new table. That creates an empty table for us, just like we did up here to create an empty array. We called make array. To make an empty table, we're going to call the table. We're going to call the table method from there. And then what we're going to do is, so that gives us a brand new table. And then immediately we're going to call the with column method on that brand new table that we created. And that is saying, give us, take that table, our brand new spanking new empty table, and we're going to add the column. And then we're going to give it the name, the label, difference between means. And then here is the data for that column. This is just the differences that we created up here. Okay, so then now, once that is done, now we have a table. We have a table with one column that has our differences. And since it's a table, we can call the histogram on that. And that's going to display the histogram for us. So those are kind of all the steps that go in there. And now if we look at this, so this is what we would get. And so this is, again, the null hypothesis. So if there was no difference between the groups, so we shuffled all the labels, we took the smokers and the non-smokers, and we computed the average birth weights from them. So this is what you would get normally to chance. And this kind of intuitively makes sense, right? On average, there shouldn't be a difference, but because of kind of how we selected things, you're going to see that, it varies. But how does it vary, right? If you look at the tails of the distribution, really everything is lying kind of pretty much between -3 and +3 ounces. And so what was the observed difference? The observed difference was 9. The observed difference was 9. So where is that, right? So this is 1, this is 2, this is 3, this is 4, this is 5, this is 6, this is 7, this is 8, this is 9, right? I mean, this is not, scientific measuring, but 9, getting a distance of 9 is somewhere out here from there, okay? And so, this is highly, so the chance for this experiment, right? The chance of getting an observed difference is, for this experiment, it was 0. None of the items had an observed distance from there, right? I mean, we can't say that it is impossible because we've only ran like 2,500 simulations, but it is pretty much as close to 0 as you can get from there. Okay. So to summarize, this is kind of the summary to how to do these types of tests. We're gonna get our 2 groups. So we're gonna, all the stuff that we've done before, we're gonna figure out the question that we're going to want to ask, and we're going to figure out the statistic that we want to compute that will either reject or confirm the null hypothesis. And so once we have the statistic, then the plan to do A/B testing is that we're going to take our table of data, we're going to shuffle all the groups. We're going to shuffle all the labels on the groups, because if the null is true, there is no difference, right? The question we're asking is are there any differences between the groups? If that is true, then shuffling the labels should not matter. So we're going to shuffle all the groups, and then we're going to run the experiment, keeping the group sizes the same from there. And then we're going to compute our statistic. We're going to do that, 2,500 times, and then look at where our distribution falls. Fantastic. That's exactly where I wanted to stop. And we're right at time. So we are done here today. Let me